Okay, am I audible? Ravi, am I audible? Rahul, Mrutyunjay, all of you are there or still having your tea?
Yes, sir.
Yes. Okay, okay. Okay, fine. So, last time we have seen instruction set for carrying out data transfer operation. Four types of data transfer operations are possible in 8085, that is between register to memory location, then memory location to register, and input output device to memory location. So to carry out all these operations, yesterday whatever PPT you have seen, all those instructions like MOV, MVI, LDA, LXI, in, out, all these instructions you can use for carrying out the data transfer operation. Now, this is one set of operation, and you can identify those instructions with this set of operation. There are other types of operation. Initially, you might have seen the arithmetic operations. So now, if you want to carry out some arithmetic operations are, for example, there are addition, subtraction, rotate, compare. All these are arithmetic operations. So now, if you want to carry out what is the format of instruction, what type of instructions are there, and how you can use those. So regarding that format, there is one simple format to write down the or to carry out the arithmetic operations. Right now, you are observing this PPT. It consists of the description to carry out arithmetic operations. So these instructions perform arithmetic operations such as addition, subtraction, increment, and decrement. Now, suppose you want to carry out the addition of two numbers. So how will you do that? So for that, simple procedure is there. That is, any 8-bit number or the contents of register or the contents of memory location can be added to the contents of accumulator, and the sum is stored in the accumulator. It means what? You can carry any 8-bit number. Suppose 16H is the number. So that you can add with the number contained by the accumulator. Always remember this. You cannot change this format. If you change the format, it becomes totally wrong. Then you are not going to get the result. So 8-bit number can be added with the number which is already existing in the accumulator, or the contents of any other register, say B, C, D, E, H, L. From this, you can add that register with the contents of accumulator. So it means here common register will always going to be accumulator. So you cannot carry out any addition operation leaving accumulator. So by default, accumulator will be one of the you can say operands. So that is more important to understand when you are. Otherwise, most of the time people, students write down add BC something like that. So add BC is never going to be possible because B and C cannot be added directly. So that is the next line. It says that no two other 8-bit register can be added directly. So this is just an example. B and C cannot be. So there are some instructions always there, like exception DAD is such instruction which can be done without that. But normally this is how addition operation can be done. So I hope you might have understood. Similar procedure is prescribed for subtraction. For subtraction, any 8-bit number or the contents of a register or the contents of memory location can be subtracted from the contents of accumulator and the results stored in the accumulator. The subtraction is performed in 2's complement and and the results, if negative, are expressed in 2's complement. Similarly, here no two other registers can be subtracted directly. So here again, the similar thing is there, that is either 8-bit number or the contents of register. You can subtract from the contents of accumulator. So this is always going to happen like that. Suppose there is a number 02H in the accumulator, and there is another number 06H. Now, even if 06H is a bigger number, you will have to subtract it from the 02, because 02 is contained by the accumulator. So obviously 02 minus 06, that is going to be -4. So if minus is going to be the outcome, in that case, it is done with the help of 2's complement. And anybody knows about this thing, what is 2's complement? If some of you have studied computers, maybe at 12th, those students might be knowing it. What is 2's complement? There is 1's complement, and after that 2's complement. So 2's complement means we will be solving also problems. That time again you will come to know. Suppose 000, 4 times 0 is the number, or I can do on this PPT itself. Okay, so on this PPT I am typing these 4 numbers. That is 0000. Okay, so now 1's complement of this number will be, that is all zeros converted into 1. So this becomes 1's complement. Okay, of the previous number. Now what is 2's complement? If you add 1 into the 1's complement, then it becomes, so here addition symbol will come over there. Then whatever the outcome that you will be getting, it will be called as 2's complement. Okay, all of you understood what is 2's complement? Now this 2's complement, actually we are going to solve the problem analytically also, and if you people are coming over in the lab, that time also you can solve those problems. So it will be again very clear concept. So these 2's complement represent a negative number. Whenever the outcome is negative, in microprocessor, you will be representing it like this. Means you will calculate the 2's complement of that number, and that will represent the number you have calculated. So later on, you can actually do that, 2 minus 6, and then you will come to know actually minus 6 should be the answer, but it is not like that. Something else is the answer. When you calculate 2's complement of that, then you get 6. So, and carry is produced in that particular process. So it becomes negative number. So in that case, carry is 1. So always remember, whenever there is negative, there is going to be the carry. So this is what done in the subtraction operation. And you people might be knowing this rules for addition and subtraction. That is, suppose 0 plus 0 will be 0. Then 0 plus 1 will be 1. And then after that, what is the result of this? Anybody knows? 1 plus 1 is equal to? It is 0 with carry 1. And one more number actually that we have 1 plus 0 will be equal to 0. So these always remember these rules when you will be actually doing the problems. That time you will be uh, able to understand these because you will be actually solving the problem. So that time you will be understanding. Okay. So this is what these are the simple rules used for this. We can say digital systems because digital systems don't understand our normal languages. So 0 to 9 already you are familiar with those terms. So this is all those you will be expressing in terms of 0 and 1. And then we need to apply these kind of rules over there. Okay. So understood these rules and two's complement, one's complement. Neha, understood or not?
Yes, sir.
Yeah, okay. But Neha Kurian, I wanted who answered? Neha Kurian, are you there? Hmm? Okay, I have shared the attendance link. Those currently present, you just mention your attendance. After 2 minutes, I will close the link. Okay, so do it fast. Till then, we will move forward. So this is what these are the rules for addition, subtraction, and those rules you will have to follow. Next, so similar principle is added in subtraction. That is directly you cannot subtract two numbers from the register. Be clear from the accumulator. In an important way, that is, they can be performed in any one of the register or in a memory location. It means what? Suppose there is some content in the register B. If you press INR key for that register, it will get incremented automatically. You don't need to do anything for that. And it is possible for one single register. You don't require pair of register to carry out this operation. So that is the meaning of these registers. So 49 students have responded. I'm closing the link now. If somebody is remaining, do it immediately. I can see some 52 students, 51 students might be there in the class. Okay, so all of you have responded. I'm closing the link now. So this is what happens in 8085. And then, so these were the arithmetic operations. Then there are logical operations. So what are these logical operations? You might be knowing logic gates and or exclusive or not, nor. So all such logic. Now, what is the use of these logical operations? There is again specific reason for that. We are having very small and simple setup in the lab. When you come to the lab, I will show you that. Means in industrial life, suppose you I want to why should we use this and or what is the significance of it? So that setup will demonstrate you how you can make those connections, and whenever required for some special conditions, you can design such circuit, and you can obtain the output which is normally there with the AND or logic. So again here, similar principle is there. Any 8-bit number or the contents of register can be ANDed or logically ANDed or with the contents of accumulator. So if you want to perform the AND operation, obviously you need two inputs, but one of the inputs will always be from the accumulator and another will be from the any other register or memory location. And both can be, or logically it can be perform AND operation or operation. Similarly, there is a rotate operation. Rotate means you are just shifting from the numbers from left or to right, right to left, like that. So there are certain requirements when you want to carry out such operations. So each bit in the accumulator can be shifted either left or right to the next position. Then there is a compare operation. Two, three numbers are there. You want to compare for whether they are equal, greater than. So like that, operations can be done. And there is complement operation. So just now we have seen what is one's complement, what is two's complement. So similarly, these one's complement and two's complement, all that can be done. But one's complement directly you can do in the microprocessor with that instruction of COMP. So one's complement means what? All zeros converted into one, all ones converted into zero. So this that kind of operation is called complement operation. And then there are branching operations. Branching means you might have performed similar operations earlier. Same, you might have used looping operations in C language or some other languages you might have studied. So, what is the significance of that loop? It directly jumps onto one specific location. It is not carrying out a normal sequence. So similar requirements are there sometimes. Suppose breakdown occurs, some raw material supply is not there. So you need to directly skip the normal procedure and directly shift on to the next some other location. So such kind of requirements can be fulfilled by using these branching operations. So these branching operations are, there are jump operation. Jump is a very simple operation as normally you have been doing. Then there are call, return, restart operation. So these instructions change the sequence of program either by calling a subroutine or returning from subroutine. What is this subroutine? Subroutine is similar to what you have been stating for loop. So it is basically, suppose you want to perform 200 operations, 200 anti-clockwise rotation for the motor. So to give that instruction, you need to write it down 200 times. So it is not practically feasible. So what you can do, you can create a loop which will carry out that operation 200 times. So that is what jump call return operations are there. So it will call that particular loop from one location, and once it is used, it will be returned or restart. Then there are machine control operations. These instructions control machine functions such as halt, interrupt, or do nothing. So these machine control operations are there. These are perhaps the most important operations that require halt. You are familiar, so something goes wrong, then you will have to halt the operation. Interrupts are something which will give signal to the entire system that something has gone wrong, and this is called interrupt operation. Do nothing is something like delays that you are adjusting. For certain operations, you need to adjust the delays. That time, do nothing. You can execute. So these are very important machine control operations. So these are all types of operations which we are doing in 8085. We have seen the data transfer, after that arithmetic, logical and branching, and then machine control. Now, for all these operations, there is a set of instructions. We will see those set of instructions also. This is something the picture, those who have already visited in the lab, they have actually used this setup. Those who have not visited, for them, this is it. So it looks like something like this. Okay, so with this keyboard, and this is how the outputs will be displayed. There is a program also at the adjacent line. Program is also written. You can find out the address C002. At that address 06 is the output or number, you can say. So the similar output you can see on this display, which is showing at the right. That is C002 is the memory location or address at which 06 is the content. So something like this microprocessor kit is there. So this is regarding all sets of operation. Now we will again move back to this instruction set. So now see all this again we will see the instruction set. Suppose you want to carry out these different arithmetic operations. So what instructions will be there? This is out using out yesterday we have seen. So it is just giving from accumulator to port location. Suppose port location is 50H. This is how you can do that operation. Again, we have just seen the description of addition. So how we can do that? So the instruction which will be used or opcode that will be used is add. Okay, so that opcode we can use. What are the operands or data on which this operation will be performed? That is R and M. Okay, R can be any register or M can be memory location. So you can add the contents of accumulator with any of the register or memory locations. So the contents of register or memory are added. After addition, whatever is the result, again that result will be stored into the accumulator. Always remember, whatever you do, it by default first it is stored into the accumulator. Then if the operand is memory location, its address is specified by HL pair. We have seen why HL pair, because it is the format of higher bit and lower bit. That format is there. So add B or add M. This is the format of writing down addition. But add B means what? Contents of B will get added with the contents of accumulator. Even though now here accumulator is not mentioned, but this is what the format is there by default. You will have to understand that this is one of the register get added with the accumulator content. Okay, so this is how add instruction can be used. Now, yeah, so yesterday you people have come, some of you, so you have seen the opcode, how you get selected. You have got the soft copy of the opcodes also. You can just find out there what is the opcode for add B. See, because this add B is for you people to understand for programming purpose, but microprocessor doesn't understand it. So it will understand only the hexadecimal opcode, and some number is there for this add B. So that number you will be typing on the keyboard. So this is how entry of different opcodes will be done. Okay, then this is the example how the data transfer takes place. So suppose accumulator is containing 04 number, register C is containing 05. This is what the status before execution. Now after execution, what becomes over there? You are using the instruction add C. So add C means what? A, what will be the content of accumulator? 04 plus 05, that is 09. That will become the content of accumulator now. New content will be 09. So this is how it is done in microprocessor kit. Again, if instead of some register memory location is there, suppose now that HL pair is indicating 2050 is the memory location. So at that location, say the number is 10 and accumulator is 04. So add M. So you are again having A is equal to A plus M. So 10 plus 4, 14 will be the content of the accumulator. So this is how actual process will be occurring inside the microprocessor. So I hope you might have understood. Varun understood? Anjali?
Yes, sir, understood.
Anjali joined late. Understood or not? Anjali,
Yes, sir,
what?
I was having some network issues, so I joined
Okay.
late.
So the next operation is the subtraction. Again, the subtraction is similar procedure which we have seen. So the number of register or memory location can be subtracted from accumulator. Again, the result is stored into the accumulator. So it is done by using 2's complement. So this will actually we will use this procedure. Then fourth is the opcode for carrying out subtraction operation. So there is opcode sub is the opcode used for that. So what is this sub operand is RM. So subtract register or memory from accumulator. So the again here whatever is the number contained by the register or memory location, you can subtract it from the accumulator. Now this is where flags will come into picture. Suppose you have done some subtraction operation, result is positive, flags will not glow. That flag which is having this status, it will not glow. But if it is glowing means one is there, that is negative number is produced, then flag will be on. So flags will reflect the result of subtraction. Always remember. Then example they have written it is similar to additions that is suppose sub B they are writing down. This is how the data transfer position will be there before execution. Now for example 09 is there, C is 04. So after execution that is sub C means contents of C will be uh, subtracted from the contents of A. So that is 05 will be there. Then before execution there is content of A, some other memory location they have indicated. So after execution that is sub M. This is something you will be getting at the output 04. There is another instruction actually. It is SUI. So what is the meaning of this instruction? Subtract immediately. Now, can anybody notice the difference between sub instruction and SUI instruction? I will just show you the sub instruction also. Okay, so this is sub instruction, and now you are observing SUI. Any difference between these two instructions? The similar difference we have seen for data transfer operation. The similar thing is being carried away. Ayush is there. Ayush, Adesh, Aditi, Aditya,
Yes.
Yes, sir.
Yes, sir. I'm Aditi.
Amar, Aniket, Anjali, Anushka,
Yes, sir.
Arnav,
Yes, sir.
Yes, sir.
Aryan,
Yes, sir.
Anush, Ashutosh is there. Atharva, Bhagyashree,
Yes, sir.
Bhushan, Harsh,
Yes, sir. Yes, sir.
Arshada, Arshal is there. Jay,
Yes, sir.
Jayan, Karthik, Kaveri, Mohammad Saif Ansari, Mrityunjay,
Yes, sir.
Yes, sir. Yes, sir.
Mugda, Munish,
Yes,
Neha
sir.
Korde, Neha Kurian,
Sir.
Nikhil,
Yes, sir.
Yes, sir.
Yes, sir.
Nishant, Nivrutti, Praful, Prajakta,
Yes, sir.
Parvasha, Pratik, Rahul,
Yes,
Yes,
Panja,
sir.
sir.
Rakesh,
Yes,
Ravi,
sir.
Desai, Ravi Parmar, Ritvik, Sagar, Sakshi, Saloni,
Present, sir.
Yes, sir.
Present, sir.
Sarang, Priya,
Yes,
Shreyas,
sir.
Yes, sir.
Shrikant, Shruti, Shubhangi, Siddesh,
Yes, sir.
Srishti,
Yes,
Yes,
sir.
sir.
Yes, sir.
Suraj, Varun.
Yes, sir.
Okay, see, I think Atharva, I think students they did not report to me, or if they have reported to you, I don't know. But we can continue with the one slot only Wednesday because um, students are not, many students are not coming for this physical presence. Okay, so should we continue like that only on Wednesday?
Yes, sir. Yes, sir.
Oh, okay. So next week also we will have the similar thing, not as per your batches. Okay, but those who are online, then they can continue like that. But obviously, with this microprocessor, some constraint will be there. But we will see. You need some practice or a different. Or I will shoot one video of one of you people, and then that video I will share with you. So the difference between this SUB and SUI is very simple. That is, SUI is used when there is directly the data, 8-bit data which you want to subtract, not the number which is contained in the memory location or in the register. So that is what happens over here. SUI, that is subtract. The meaning of that SUI is subtract immediate from accumulator. So suppose now they have given example SUI 05H. So if you are subtracting any number, suppose they might have given the number. Suppose this is the content of the accumulator, that is 08. So it will be subtracting 05 from 08, and after execution 03 will be the output. So this is how you can do for subtraction operation. Then we have already seen this increment, decrement. This is very easy. Actually, you can just press the INR button. Those who were there yesterday, you people have already seen INR, DCR keys. So if you are pressing those keys, directly this operation will be performed. So again, for that, what is the format of writing down instruction? So INR is the code, opcode used for it, and operands that the data. So that is INR. R means for any register. It is a generic form. So R can be replaced with B, C, D, E, H, L, any register. And M is the memory location. You can replace that with any two memory location. So here, example is INRB. So this INRB format, always remember this is called mnemonics. This is the language of microprocessor that is combining opcode and operand. So sometimes you get confused what is mnemonics. So this is something, the example is written in instruction format, that is mnemonics. So this is the uh, data transfer position before execution. Suppose B is containing the number 10, then you execute the instruction INRB, means you are incrementing the contents of register B. So simply 1 will get added to 10, and then you will get the output as 11 after execution. Similarly, INR M. Now M is a general form. You can write down any memory location. So you suppose you are writing down INR 2050H. So again that will increment memory location. It will move on for the add number, and it will contain the next number, that is 11. If it is having some data, if it is not having data, then it won't be there. Similarly, the decrement operation can be done. Contrary operation to increment. So this DCR, example DCR E is given. So E is containing 20. After execution of DCR, E will be containing 19. So this is what happens by using increment and decrement key. The characteristic of this increment and decrement operation is that only you can perform it with the single register, nothing else. Then again, if memory location is there, you can find out from there 21 DCR, mean decrementing by 1, you will get the result as 20. Then there are logical instructions, perform logical operations. These are AND, OR, XOR, compare, complement. These operations are there. The first logic operation is ANA, that is AND operation. So what is this ANA? You are logically ending the register with the accumulator. This is what operation that you are performing. Now what it means, how do you carry out? They have given you one example, that is ANAB. Now what does it mean? This is where the numbers are given ANAB. It means what? Suppose uh, accumulator is containing the number AA. ये किसी को you people know this, what is this AA? AA means what? AA belongs to 10. In hexadecimal system, A is equal to 10. So how this 1010 corresponds to A? Anybody knows it? If not, then I will just give you hint so that you can also do it. Nobody knows it. Are very simple. Oh, you don't know how to convert this number into binary system. I will just let me check this. So suppose this a is equal to 10. So how to convert this 10? So we have just seen something like 1010. So what is this 10? That is suppose means you can. I will just write down. So 2 raised to 0. Then it will be added with the 2 raised to 1. Then 2 raised to 2 and 2 raised to 3. So that is how it becomes. So 2 raised to 0 is what? 1. Here 2 raised to 1 is what? 2. 2 raised to 3 is what? 8. But 8 into 0 becomes 0. And 2 raised to 4. What is it? 16. कितना है 2 raised to 0 1 2 3 8 8. Are you getting this or not? ये 0 से मल्टीप्लाई करने के बाद दिस इज अगेन गोइंग टू बिकम 0. So if you add this 8 and 2, it will be 0. Sorry, 10. Getting this conversion of binary into the number system.
So can you please explain this again?
Huh. See, now you are having a number 10. Okay, so now that you 10, this 10 number actually, as per procedure, you will have to go divide it, go on dividing it by 2. So it becomes 1010 later on. But right now you can directly start with this. That is what you require 10. So obviously we start from 2 raised to 0. 2 raised to 0 is what? 1. Then 2 raised to 1. So it becomes 2. 2 raised to 2, it becomes 4. And 2 raised to 3, it becomes 8. Okay, so basically you want 8 and 2. That's all. 8 plus 2 will be 10. So always remember you can always start with this 0, 0, 0 and 0. Then whatever number you want, you just make it 1. And now we want 10. अरे क्या हो गया? So we will just make this 2. So here the last number is 2 raised to 3, that is 8. This number that is red, I am marking it red. And this number is 2 raised to 1, so that is 2. So you will get the number equivalent to 10. That's all. Suppose I want number is only 08. So what you will do? So you will be having 8 number. Okay, you will be having 8 number. If you want 5, so accordingly you can do. Understood now? Who asked the question?
Yes, sir. Got it. Thank you.
Oh, okay. So this is how you can convert the numbers whenever the requirement is there. Can anybody tell me now? I want say 05 number very fastly. Can anybody tell me what will be there? I want 05. So what binary conversion will be there? Fast. It should be within a minute. You should be able to
Zero
answer.
one zero one.
0101. Okay. All of others have also understood. So it is right. Because see, you want 4 and 1, that's all. So 4 means the third number that you want 1, and then 2 raised to 0 is always 1. So 1 into 1, that is 1. So you require only 4 and 1. So that only you will make 1, rest will become 0. So anyway, while actually solving the problem, I will not be directly moving ahead. I will ask you to solve the problem so that we will understand, and then that is at the time of programming. Okay. So for today, we will stop here. Uh, so attendance is already over, so you can leave the meeting. Okay. Thank you.